In today's lesson, we are going to be looking at the midpoint of a line again. However, we're going to be looking at some geometric properties involving the midpoint of a line. So just a little bit of review. We want to take a look at the slope formula again, because this will come into play in some of what we're looking at. Right? So the slope formula, or M, remember when we're dealing with slope, or M, we're probably dealing with the formula y equals mx plus b. Right, that is our slope-intercept form of a linear equation. It gives us the slope, which is the m, and it gives us the y-intercept, which is the b. Slope, or m, is also known as rise over run. Right? How far over, or how far up or down you go versus how far left or right you go. We could rewrite slope as delta y over delta x. Remember, we talked about a bit about this before. The delta, or this triangle, just means the change in y divided by the change in x. So if we're looking at a table, we see what the values change by. Or there is a algebraic method, y2 minus y1 divided by x2 minus x1, which are the values of a point. Right, so for example, let's just say we have the hypothetical table of values, x and y. We have 5 and 6, 4 and 2. So if I wanted to find the change in y, change in x, or the slope, change in y would be what are the y values changing by? Well, here they go down by 2, so -2. Delta x, oops, there's too much there. Delta x, or the change in x, talks about, okay, what is x values changing by? Well, they're increasing by 1. We put that together. M is equal to -2 over 1, or just -2. So that would be how you find your slope. Again, if we were to do this algebraically in a different method, right, we might say, okay, we do the y2 minus y1. Well, in this case, we have our 2 points, 5, 4, and 6, 2. Well, 5 and 4, these are going to be our x1 and y1, the x and y coordinates of the first point. 6 and 2 are going to be our x2, y2, the x and y coordinates of our second point. And if we plug that in to our formula here, we would have 2 minus 4 divided by 6 minus 1, which gives us -2 over 1, or just -2. So different ways that we could go through and calculate slope. Whichever way you prefer is up to you. You might prefer the change in y over change in x from a table, similar to what you might have learned last year, or this algebraic formula here, this y2 minus y1 divided by x2 minus x1. With slope, one of the characteristics, or one of the specific scenarios that we looked at, was perpendicular lines. And perpendicular and parallel, for that matter, all deal with the slope of a line. So what do we know about perpendicular lines? Well, for perpendicular, we should know that they cross at 90 degrees. So perpendicular means two lines cross at 90 degrees. Right? So we're looking at something like this, where we see this, this little square. Right, 90 degrees is where our two lines cross. So something like that. Now, when we're talking about perpendicular, there is something specific about the slopes. And we did talk about this all the way in one of those review lessons at the very beginning of the year. But perpendicular, in terms of slopes, means that slopes are negative reciprocals. And all this means is just a very fancy word for saying opposite sign and flipped. So our slopes are going to be flipped and the opposite sign. So just a quick example, right? If we want, just so we can have an idea, right? A quick example. M is equal to, let's say, -2 over 1, the same one we had. Well, the perpendicular line for that, or the perpendicular slope for that, would be, let's flip it, 1 over 2, and it's now going to be a positive slope instead of a negative. Now, one thing to keep in mind, let me just write this out a little bit neater. 1 over 2. One thing to keep in mind, the opposite sign does not mean each individual value, right? It does not mean I make the 2 a positive and the 1 a negative. I'm talking about the whole fraction, right? If I look at this whole fraction, this first one, negative 2 over 1, the whole thing is negative. If I look at the second one, the whole thing is positive, right? Or if I divide the two numbers, do I get a negative or a positive? That idea. So it's the whole fraction that we're considering, not each individual component. Right? So let's say another example. Let's say our first one is 5 over 6. I want to find the perpendicular slope to a line that has a slope of 5 over 6. I need to flip it, so 6 over 5. And if I look at the first one was a positive fraction. For my second one, it needs to be a negative fraction. So I could make it negative 6 over 5, or I can make it 6 over negative 5. Either would be the same thing. The overall fraction is negative. You may just also put the negative in the middle, negative 6 over 5. Right, so those are examples of what we mean by perpendicular slopes or perpendicular lines, some of the characteristics of them. Keep in mind the b value, the y-intercept, does not affect whether it's perpendicular or not. It's only the slope. So we're going to continue and look at some specific examples of dealing with the midpoint. Right, so example 1, we want to determine an equation for the median, which is the line segment joining a vertex of a triangle to the midpoint of the opposite side for vertex Q. So a key thing we want to highlight here is the word median. This is a new term that we are most likely learning, and the median is the line segment joining a vertex, just a fancy word for a point, of a triangle to the midpoint on the opposite side. And I'm looking at vertex Q. So what that means is I am dealing with this point right here. And this is the point with the coordinates 4, 6, if we can't really see that. And I need it to form, or I need to determine an equation for this point and the midpoint of the opposite side. So the opposite side in this case is this side right here. So I need to find the midpoint. I'm just going to write in these coordinates, negative 2, 0, and 5, negative 3. So I need to find the midpoint of this line. I need to find what is that value. Well, we did have a formula from before. We learned this yesterday, how to find the midpoint of a line segment with two endpoints. I basically take the average of the x values and the average of the y values. So I'm going to say that this is x1, y1, x2, y2, just to keep it consistent. So for my midpoint, x1 plus x2 divided by 2 equals negative 2 plus 5 divided by 2 equals 3 divided by 2 equals 1.5. Nice decimal, so I'm going to leave it as a decimal just because I like working with decimals over fractions. If it was a messy decimal, then maybe you want to leave it as a fraction to keep it as an exact value and not worry about any rounding errors. For the y value of my midpoint, y1 plus y2 divided by 2. So we have 0 plus negative 3 divided by 2, which is negative 3 divided by 2, which is negative 1.5. So I have two coordinates now. So I know my midpoint is 1.5 and negative 1.5. So let's go through and now we can actually accurately plot that. So right about there is my midpoint, 1.5, negative 1.5. So I found my midpoint. This is halfway through this question because I needed to find the midpoint of the opposite side of vertex Q. Now, the median is the line that goes from that vertex to that median. So this line right here, this dotted line, this is my median. And I want to find an equation for that line. So this is going to bring back a little bit of what we would have learned in grade 9. So if I want an equation for that line, I need it in the form y equals mx plus b. That is going to be the easiest one. Now, right, I have 2 points. So this is like one of your 2-point problems in grade 9. I have the 2 points, 1.5, negative 1.5, and 4, 6. So I want to find the equation of a line that goes through those 2 points. First things we're going to do is we're going to find the slope. We're going to find the slope or the m value. So different ways you can do this. Right? You may put this into a table with an x and y. So we have 1.5, negative 1.5, and then 4 and 6. And let's look for our change in y and change in x. So y goes up by 7.5, and x goes up by 2.5. Now with those two values, m equals change in y divided by change in x, which is 7.5 divided by 2.5, which equals 3. So that means right now for my equation, I have y is equal to 3x plus something. Right? I don't know what that b value is. So this is where I'm at right now. Let me just move it down a little bit further. So this is where I'm at right now. The next step is to find b. I'm looking for this b value now. So the next step is sub in a point and find b. So different points we can use. We have 2 points, right? So we have to use one of them, right? Either the 1.5, negative 1.5, or the 4, 6. I'm going to use 4, 6 because nice numbers. I don't want to deal with decimals. Decimals are better fractions, but whole numbers are better than decimals. So now that I have my point that I'm going to sub in, I'm going to take my equation, y equals 3x plus b, plug in my x and y from this point. So 6 is equal to 3 times 4 plus b. 6 is equal to 12 plus b. Move the 12 over. Becomes 6 minus 12 equals b. Negative 6 equals b. So now I have an m and a b. So therefore, y equals 3x minus 6 is the equation, we can say is the median from vertex Q. So B is the median of vertex Q. Or not B, sorry. Y equals 3x minus 6 is the median for vertex Q. Right, so that's the equation of that line that goes from the midpoint of one line to the vertex opposite of it. Next question is a little bit similar. We are going to be using kind of these components to look for something unique, right, or a specific geometric property. So the Montreal Canadiens and their minor team, the Laval Rocket, are discussing building a new practice arena. Montreal and Laval are located at points P, -1, 4, and Q, 7, -2 on a map. The two teams want to find a location equidistant or same distance away from the two cities. Use an equation to represent possible locations for the practice arena. So if I look at these 2 points, P and Q, right, just bold these up a little bit, -1, 4 for P, and Q, which is 7, -2. So let's say one of these is Montreal and the other is Laval. So 2 cities, right? I need to find something that is equidistant or equal distance between the two. So one of those possibilities is the midpoint, just halfway in between those two values, right? But if we look at kind of the triangles that's drawn, there are many possible values that are equidistant away, right? I could have a point here. I could have a point here, and that would be equal distance away. So anything along this line here, anything along this line going through the midpoint is equally or the same distance from either endpoint of P or Q. And this right here, this is called a right bisector. And a right bisector, by definition, passes through the middle. So you can probably see what we're going to have to find. The middle of a line segment and intersects at a right angle. Because we see this right angle here. So it intersects at a right angle and it goes through the midpoint. So we need to come up with an equation for this right bisector because that would represent all possible locations for a practice arena, right? We didn't say how far away it had to be. It just has to be equal distance between the 2 cities, right? So there are obviously practical ones and there's ones that are impractical, but we don't care about that. We just want to make sure that it's the same distance from either city. So I need an equation for this right bisector. So first things first, we know it's passing through the middle. So let's start with that. Right, so the first thing we're going to do is we're going to find the midpoint. So we do have 2 formulas, or we have the formulas for the midpoint. We've dealt with this in the previous lesson. We just did it in the last example. We have xm and ym. So xm is equal to x1 plus x2 divided by 2. Ym is the same thing but with y's. I have my 2 endpoints to find this midpoint here. Now it is fairly easy because we can kind of probably see with that right bisector drawn where that midpoint is. However, that might not always be the case. You might just be given a line and asked to find the right bisector. So x1 and x2, I'm going to use Laval as x1 and y1, and Montreal is x2, y2, just keeping it consistent left to right. So x1 will be -1 plus 7 for -2 divided by 2. xm equals 6 divided by 2. xm equals 3. For ym, same idea. 4 plus -2 divided by 2. Ym equals 2 divided by 2. Ym equals 1. So that means our midpoint is 3, 1. So that's the first step, finding that midpoint. Now the next thing we need to do is we need to find another point, or we need to do something to help us come up with the equation for this right bisector. Right? I don't know any other points on that line, right? Yes, I have the graph, so I could probably look through and find some other nice points. However, let's assume that we don't know or we don't see that right bisector drawn, just because that might not be the case, or that might be the case where we don't have it drawn. So we have to use something else. So if we don't have another point, what else could we do? Well, we do know that it's going to intersect at a right angle, or in other words, be perpendicular to our one line that we do know. So what we can do, our next step, is find the slope of PQ. So we're going to find the slope of this line. So different ways you can do it. right? We'll just kind of stick with an easier way, just using the table, right? So we have -1, 4 for our 1 point, 7, -2. We look for the change in y and change in x. Y decreases by 6, and x increases by, let's see, so -1 to 7, it looks like it increases by 8. So now I have my m, change in y divided by change in x, is equal to -6/8. Now that's the slope of the line that's given to me. If I want the slope for the right bisector, I need to find the perpendicular slope. So that means if I take my slope, m is equal to -6/8, the perpendicular slope is going to be flipped 8/6 and opposite sign, which is positive, right? So this overall fraction is positive. Now, I have a slope, I have a point, I can use that to come up with an equation. So we're almost kind of where we were in the last step. That's not step 2, that's step 3. So the last step, use perpendicular slope and midpoint to determine y equals mx plus b. So y equals mx plus b. I have an m value, so y equals 8/6x plus b. I have a point, 3, 1, that I can plug in. So 1 equals 8/6 times 8, then 8/6 times 3 plus b. 1 equals, we got 24 divided by 6, or 4, plus b. Move the 4 over, we get -3 equals b. So now I have enough information. I have my slope, I have my midpoint. So therefore, y equals 8/6x minus 3 is the right bisector. We could say of PQ if we wanted to. So kind of a few steps, but it's all using things that we've already learned. We've learned about midpoint, we've learned about slope, we've learned about determining the equation of a line, right, from previous units or previous lessons or in the past or previous years. So a lot of already known concepts, but now we're just applying them to some specific geometric properties, such as this right bisector. Again, passes through the middle, intersects at a right angle. So we do want to make sure that throughout this unit, we recognize some of these key terms, like right bisector we just mentioned, and then median on the previous one. So all the math that we're doing right now is math that we've done before, or hopefully we've seen before. We're just applying it to some new geometric properties that we are learning about.